a perfect right triangle and measured, tell me what your measurements were. Amanda, what was your grade? 6, 12, and 13.5? Okay, so here's my question. We know that that's a right triangle. Let's try your theory. If I cut the 6 in half and made 3, and I added it to 12, does that give me 13 and a half? No. And let's try Juliana's theory. She said they added them. So 6 plus 12, does that equal 13 and a half? No. What are we thinking? Nathan.
You get both the sides and you square them, and then you divide, you get the square root of those.
Say that again.
You get the square version of both the legs.
So take the legs and square them. So you're saying take a leg and square it, and then take the other leg and square it, okay?
And add them together.
And add them together.
And then get the square root of that.
And then take the square root of that. Okay, let's try it. So my legs are 12 and 5. Do you think, does it matter like which one I put first? Okay, so let's just do the 12 first. So if I do 12 and I square it, and you said take the other leg and square it. Okay, well 12 squared is 144. 5 squared is 25. So what do I end up getting? 169. And then you said to do what with the 169? Are you saying that this hypotenuse should be 169 feet?
No, you get the square root of that.
Take the square root of that. So you're saying I squared both of these and added it together, and that should give me this number. Well, what is the square root of 169? What does square root mean? Let's think back. What times itself equals that? Okay, so what number times itself equals 169? Figure that out.
14 and 13. 14. Yeah, it's a little bit.
Yeah, so 14 times 14 gives me 196. Too big. So 13 times 13 gives me 169. That's the square root.
Good afternoon,
And
Highland Middle
so
School.
in theory, this should be 13 feet if that works.
And
Here's what we're going to do. We're going to stop for announcements. If we have time after announcements, we'll finish. Otherwise, we'll finish tomorrow. We'll see, right? I don't know. We'll try it. We'll try some others.
Joining me this afternoon for the pledges are 8th graders Sierra Tyrell, Damian Joseph, and Jacqueline Marino.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And now the Texas pledge.
Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible.
Thank you, and now let's all go into a moment of silence. Thank you very much. Just a couple of announcements today. First of all, we would like to thank our 6th grade students for being so successful in their silent passing periods over the last 2 days. That was a very, very impressive, very impressive showing. We actually, as administrators, we were standing in the testing areas, the different hallways, and we never even knew it was passing period for 6th graders. So they are phenomenal. So thank you very much, 6th grade. One sour note on testing yesterday with the gumshoeing, it was unfortunately reported by the custodial staff that we had a large number of gum mess in the 7th grade hall. So we'll be revisiting as to whether or not our 7th graders will get the privilege of gum on testing days. 8th graders, we had one particular spot that was messy, but other than that, most of it was, again, upstairs in the 7th grade hall. So it's probably just that 1 or 2 7th graders, maybe 3, that might blow it for the whole group, and that's just a shame. Other than that, we had very successful testing days. Thank you, teachers, for your flexibility. Thank you, students, for your respect for others and maintaining a quiet environment for testing. Overall, we had 2 very successful days. Thank you, Ms. Kono, for your hard work. Those are all the announcements I have today. The quote for today: success comes from taking the hand you were dealt and using it to the very best of your ability, and that was spoken by Ty Boyd. That's all I have. Thank you for your attention, and as usual, it is a great day to be a Highland Hawk.
Okay, so back to what we're doing. Let's flip. So we have this group that's saying if you take the two legs and you square them, and they found if you add it together, whatever your answer is, if you take the square root, they're saying that should be your hypotenuse. Now over here, Breck and Kaylee's group, they said they made a right triangle and the sides were 6, 12, and 13.5. Well, that means if this is true, what Nathan's group said, then in theory, or sorry, what Dave, I don't remember, yeah, Nathan's group said, then in theory, it should work on this one. So let's do, okay, so wait, you did 6 squared, right? Because you're assuming that these two are the legs because they're the shorter ones, I'm guessing? Okay, so 6 squared is 36. 12 squared is 144. And when you added them together, what did you get? 180. So, I need to take the 180 and do what with it? Square root it. Okay, is that going to give me, is 180 a perfect square? Am I going to get a whole number? No, because if you think about it, 13 times 13 is 169, and then 14 times 14 I said was 196, too big. So let's go ahead and look at this. 13 squared is 169, 14 squared is 196. Remember back a while ago we talked about how to estimate square roots? We want 180 to go in there. Where is it going to fall? Is it going to fall exactly in the middle? Or is it going to be a little bit closer to the 13 or a little bit closer to the 14? What's exactly in the middle of here? It would be like...
No, it's closer to 13. Yeah, 13.
It's a little closer to the 13, right? It seems like if we were right in the middle between 169 and 196, we would have... Right in the middle would be like 182 and a half, 182.5. So we're slightly closer to the 13. So when I'm estimating, it's not going to be 13.5. It's going to be slightly closer, so maybe about 13.4-ish. Is that really close to what we got up here? Yeah. So far we found 2 different right triangles where this rule seems to work. It worked down here if this really was 13, and it worked up here with the one that they made. So tomorrow where we're going to pick up is we are going to keep looking at some of these triangles and see, does this rule work every time? Does it only work on some? We'll take a look at that. So right now what I want you to do is leave your colored, the construction paper tasks on your group desks. I want you to go ahead and start getting your stuff. The bell's about to ring. Think about this tonight. Come up with a thought. Do you think this works? Do you think it doesn't? What is going on with this?
Hey guys, it's awesome.